Hello everyone, thank you for coming to my talk. So the talk is about computer vision and it's titled Beyond the Brain Using Computer Vision to Unlock the Potential of Video Data. So first of all, my name is Paula, I'm a computer engineer in Noumena. And to give some notes about my background, I studied audiovisual systems engineering and then I'm doing a master's degree also on deep learning. And I have been working in a hospital doing disease detection algorithms. And now I'm working in Noumena, which I will explain now what it is. So Noumena is a startup in Barcelona that basically its mission is to develop metrics and instruments to empower decision making towards more efficient, resilient, and sustainable spatial solutions. So the way that I structured this talk is that first I'm going to give a brief introduction about computer vision, and then I will explain in more details how we did one project in my company. So first of all, what is computer vision? How come computers are able to understand images? So for me, this is a very interesting topic. And the answer to this is that computer vision is a field of artificial intelligence and computer science that focuses on enabling machines to understand the visual content around us. Um, and these algorithms, what they do is that they analyze the content of the images, like including shapes, colors, and motions, and from that they extract features. That these features then can be labeled and used to train different algorithms that are powered with machine learning techniques. So a workflow of a computer vision algorithm is the following. First of all, you have the data collection, then you do usually some pre-processing to this data, you apply the algorithm, and then you do some post-processing to this data to extract meaning to it. So first of all, the data collection. And this is a key factor of computer vision and any of artificial intelligence algorithms, because of course your model learns from the data that you provide. So you need good data. And to have good data, what does it mean? So first of all, you have a list of requirements that you can see here. That the first one is that you need large amounts of data. So for instance, the model that we will use in the further example was trained, I think, with around 1 million images or something like that. Then, of course, you need a variety in the dataset. So you want your dataset to have as multiple and different images as possible. So you build robust algorithms. Then you want it to be balanced. So for instance, in this case that I put here an example, you have dogs and cats. So it's a multi-class model. So you want to have more or less the same amount of cats and dogs. So your model doesn't have any biases. Then you want your images to be representative of whatever you want to detect. And of course, this is obvious, but you need it to be well labeled. Okay, and to have all this data set is normally kind of expensive, or maybe you just don't have it in your company. So what we use a lot is to use open source data sets. That the most common one is Coco. Well, here I put some links. But what you can do is that you can use open source data sets that you found online, that they are already labeled, so it's easy to use. And then if you want to train your models for different classes, for instance, you can apply transfer learning, so you already have a good base of images, and then you don't need to apply to do so much manual labeling. And this is a way that you can gain some time. And now we go to the step of pre-processing of the data. So normally I categorize it into steps. First of all, well, if you work with images or videos, first normally you check the images. So you see if the images have good colors, if you're able to distinguish the classes, if they are of good quality. So depending on your data set, you will apply different things. So for instance, if you're recording videos in the street, maybe the colors are not good, so you apply some normalization or you enhance some images. And then in the case of video, what is very common to apply is almost always we do some subsampling of the frame rates, because now cameras record very high frames per second. But usually you don't need as many, and you are like just inputting a lot of images to your algorithm. So normally we do a subsampling. Then of course, depending on the quality that you want of the image or like your objective, you can rescale the videos and make it smaller. So for instance, if you're doing object detection, you will not do that because you need a lot of definition. But if you're doing object detection, maybe yes. You can normalize the videos, and of course then you encode it and feed it to the algorithm. So now it will come the part of the algorithms, that this is the tricky part, and I could be like a whole presentation just talking about one. So what I did is that I put here the ones that are more used, that for instance are object detection, then you can do post-estimation for person or for animals. You can do semantic segmentation, instant segmentation, face recognition, that you can see there my face, and it's pretty accurate. Then you can do tracking as well. So you, depending on your use case, you can develop an algorithm or use some that are online, open source, and there are many of them. And then, of course, you do the post-processing of the data. So normally, what you do is that you apply the algorithm, then you get some results back, but you have to check the results. First, check that if they are all right, and then maybe you take out the outliers, you do some thresholding, and from that you try to extract meaning, and usually you do some visualization so the client is able to understand all of these numbers. Okay, now what I will do is that I will explain the real case scenario, so a project that we did in our company, that is actually the first one that I did when I came to the company, so for me it was kind of special. And this project is about the monitoring urban spaces in Barcelona. So basically this is a project that we did together with the municipality of Barcelona, and the idea is that they want to understand how people, bicycles, and vehicles are interacting with each other. And this is because now in Barcelona we are changing the structure of some streets, so they wanted to know how the people that is interacting before they change the streets, and then they want to know what is going to happen after and how the people change their flows of movement. Okay, so of course to do this project we followed the structure that I just explained to you. And the first step was the data collection. In this case, what we did for the dataset for training was to use the open source dataset that I was mentioned, that is Coco, that I think everyone that is in this industry is using it. And then we have the prediction data, so the data that we used to analyze the data, that was the one that we recorded from the streets of Barcelona. So here you can see an example of this is the Coco dataset, and then you can see the type of images that you can get and that they are labeled. And what we did in this case, that the classes that we are interested in were the cars, the bikes, the motorbikes, trucks, and pedestrians. And so you have the dataset, you can download it and use it. And then for the data collection of the prediction data, and what you see here is a picture of the streets of Barcelona, and the green dots is the places where we installed cameras. In this case, what we did is that we installed normal RGB cameras, 7 of them, and we were recording for 3 days. And these 3 days were Monday, Thursday, and Sunday, just because we wanted to understand how the people are moving in the different days of the week. And also, it's important to take into consideration that this was August. So people in August move in a ways that they don't move in winter because of temperatures and so different things. And what we did is that we were monitoring 2 streets, so both that are the one that is in the top and the bottom, because this one here, this one here is the one that is going under construction, that is actually this year has finished, so now it's a completely different street, and this one is staying the same. So in this way, we're able to compare how the people are moving. Okay, well, here you can see the cameras and my colleague installing them. And okay, so we recorded the videos and we had around 6 gigabytes of data. And this data that we recorded also, we applied some pre-processing, which in this case was that we reduced the frames per second, because I think we were recording at 30 frames per second, but then testing the algorithms, they were working just as fine with 15 frames per second, so we reduced all of them. And then we also correct the distortion. So I don't know if you can notice, but in the image of the top, what we did is that normally all the cameras have some kind of fisheye effect, and you don't want that because they distort the persons and the cars and the bicycles. So in order to increase the accuracy, you normally flatten the image, so you have a perfectly normal shape of the classes. And then here we also implemented this that we call that they are corridors, that you can see that there is the pink, the blue, and the yellow. And this is because in the city of Barcelona is kind of a complex environment, because, well, and every city, because people move weirdly, bikes are parked everywhere, motorbikes are parked everywhere, maybe a truck is in the middle of the camera, you don't see anything. So this was like a little trick that helped the algorithm improve the accuracy, because with these colors, we said to the algorithm, what are you expecting to find in these places? So in the pink, you're expecting to find persons. Of course, you can find it in different places, but in this way, these detections had much weight than the others that they were not in the expected places. Okay, now for the part of the algorithm. So we have done the data collection and the pre-processing. And now for the algorithm, what we did is that we decided to use YOLO, in this case YOLO 7, which was the one that was available at the moment. That is an open source project, and it's trained with the Coco dataset, that is one of the most used, and I think it's the one that works best in the industry now. And so what we did is that we downloaded this pre-trained model and then choose to detect the classes that I showed you before. And then so this was just to detect if it was in the image a bicycle, a car, or a person. And then what we wanted to do is to track them over the over the frames and also how it is moving. So we applied a tracker that in this case was Norfair, that is a tracker that is very used in Python because it's kind of lightweight, so you are able to put it in any model that you are using. And then we implemented both of these algorithms and created a code that was able to extract the data that we wanted. And we also implemented a counter because the municipality of Barcelona was very interested in knowing the amount of persons that were in the street at every 5 minutes or like in a given amount of time. Okay, so now we ran the algorithms that it took like kind of a lot of time to run. And then we had the data. The data set, this is a capture of the data set that we got. That was, we had the time, the amount of cars, persons, and bicycles, because this was the first step of the algorithm. Then in further iterations that we have been doing, we also have the points in the tracking, so we can plot in the map how the people were actually moving. But for this iteration, we did the counting. And the first step was to check the data, make sure that it's all right, clean if there is something that is not okay. And then what we did is that we created some visualization for the people to understand what is happening. So here you can see some of the visualizations, and basically what this represents is that, well, these are the streets, and then you can see the amount of people, bicycles, and cars that I think you cannot see it very much, but that they were in each street. And for instance, the last image is Sunday, that you can see that there is much more people, because on Sundays people don't work, so they are out in the street. And then you see that more or less now the amount of bicycles and cars are kind of the same. There are more cars than bicycles, which is something that they are trying to change with this restructure of the streets. And well, and the amount of people varies a lot with the hour of the day, because I don't know, at 11 everyone is working, in the afternoon there is more people, so it depends. And then what was also very interesting for this project is that we had to calculate the accuracy. Well, you normally know the accuracy of the algorithms and you calculate it, but in this case, the municipality was very intrigued because they wanted to know if they can apply this usually, or they need to find other ways to maybe put sensoric on the ground, or different ways that they can do it. So what we did is that we calculated the accuracy of this algorithm. So basically this means that we took videos that were run in the algorithms, and then a person was labeling them and counting the people, and then we could compare how the model was working versus how the persons I don't know, are able to see it. And what we saw is that we have pretty good accuracies because, of course, you can always improve, but given that it's in a state in Barcelona, that there are a lot of shadows, that people are moving, the trucks are in front of the camera, that we were not able to put the camera in the ideal place because normally you have to use, well, they give you designated places. So in our case was in the top of a lamp, so you have like a weird perspective. So there's a lot of things. But given that we had this situation, the accuracies were very good, but the one that was worse was the one about the bikes. And this is because since we had the camera from the top to the bottom, you can see the person in the bike, but sometimes you cannot see the bike. So to solve these things, normally you can do some labeling of this data set and then retrain your model so it's able to understand that this is a bike, even though there is a person above the bike. But the results were quite good and people were happy about it, so we were happy. And well, this was the end of the computer vision project. And now I will explain like some lessons learned and what will be the next steps that we should do to improve this model. So first of all, one thing that was very tricky to us is that of course, you calculate the time of execution of your algorithm, so it depends on the GPUs that you have, the amount of videos. So we did our calculus, and we had, I don't know, maybe 3 or 4 days of running algorithms. But then, and we did some tests, and it was fine. But then when we put all the videos to run, so we created like the flow, so I don't know, we will start with Monday, and then we go Thursday, and so on, we saw that the algorithm kept crashing. So we revisit the algorithm, go step by step, and everything seemed to be fine. And finally, we look at the videos, and they were corrupted. But of course, the videos that we did the test were perfectly fine, but all the rest of the video apparently were corrupted. So we had to run some ffmpeg commands to decorrupt them, which is not a big deal, but the deal was that we had said that we will have this in this amount of time. And now, when we have to run this decorruption step, it took the same amount of time that we have planned to run the whole algorithm. So in the end, we were like just stealing computers in the office and make it work. But of course, seeing this now in perspective, it's better to have double the time and you're fine. Then also, since there is this weird situation that there is a lot of shadow trees and, I don't know, kids running around, we decided in the next step we will try with higher definition cameras, because in this case, I think we're running the cameras at 640 by 480, so very low definition because the classes are pretty big, so you can see a track from a distance. But giving, like now, understanding the context of it, and maybe we will try something with more definition. And the last one is the most important one, and this is that this type of projects depend a lot in the space that you're monitoring. So if we were monitoring only 2 streets, with 7 cameras was okay, but if we wanted to do it in the whole Barcelona, we need, I don't know, 1,000 cameras. So if we need 1,000 cameras, we need a full room in the office full of GPUs. Or like, you have to think a lot about the infrastructure and do like put our money and then change the structure of your company, maybe. So what we are now implementing is just to run these algorithms on the edge. So meaning that since we are already developing the cameras that we use for recording, what we want to do is that while recording the videos, we are already processing these images. So meaning that we will run the object detection algorithm and the tracking in the camera. And then what you are sending to the database is just the information. So maybe a car in this position at this time, but you are not sending more information or saving the videos, which also is a lot of memory. And now we're developing this, and that's it. That is the end of my presentation. I hope you like it, and if you have any questions, please.
As usual, now is the time to ask questions. Are there any? Okay. Okay, first one.
The last bit was fascinating about effectively doing the detection at the edge and then just streaming the data rather than the raw video. And what kind of hardware do you need out at the camera end to be able to do that?
Now, I'm not the one developing the camera, but I know that we are using, so just to record a video and save it, we were using Raspberry Zero, I think. But now these ones are gonna crash with the algorithms that we have, so now I think they are trying with bigger ones. I don't know which one actually. I think they tried with Nano, was kind of not working, and I think now they will put, I don't know, maybe Raspberry. I think we have Raspberry 4, but maybe this is too powerful, so you have to find like a balance, because also you are putting these cameras on the street, so you don't want them to get like, if they are too expensive, maybe you don't want to set in this. Like, there's like a fine line, you know? Like if you have good hardware in the street, maybe. Yeah.
Hello. You talk about like the Coco dataset and like the image processing, like in the like you just process a video as a bunch of like a single frames, and they are like learned from the like Coco or ImageNet. But then, have you thought about does that algorithm takes like the context of like the other frames? I mean, when you like see a bike and a person as like a single frame, it may be hard to like see that, for example, from some height, to see that it is a person. But if you have a context of video that the bike is quite faster, then maybe it's like easier to predict that something is a bike. So my question is, does that yellow algorithm just take like the videos as videos, or just frame by frame?
Now, what I understand is that it goes frame by frame. So then you apply your tracker, and then you're able to see where is it going. So you could do it this like in pre-processing the step. So maybe if a class is going this distance in this amount of frames, it's probably not a person or a very fast person.
Yeah.
You know, Usain Bolt, but
Yeah.
but you could do this.
Back to the moving the computing to the edge. So it makes total sense that you want to do that and then just have the result in your server. But I suppose on the other hand, you have to trust that the recognition was right, etc. Do you have like any way to
know,
or either to know or maybe to save some of the video just for later analysis, just to make sure, or how do you do it?
Yeah, like now, like also depends on the project, because for instance, in urban spaces, now we have been doing a lot of them, so now we are pretty sure how our algorithm works. So we could try, well, I think you will save some videos just to check, but you feel comfortable about the algorithm, so maybe you just implement it, and I don't know, you have also multiple cameras, so maybe if one crashes, it's not so bad. But depending on the this is the thing that depending on the project, maybe it's too risky to not save the data. So we were also investigating the possibility that maybe the camera, so we had, for instance, a room, so we installed 5 cameras, and then these cameras are sending the videos to a centralized unit, and then this unit is the one that is processing. So maybe in a given moment, we can enter this unit and check that everything is right, and even see the videos. So it depends how comfortable or how is the space for you. Like, I don't know, depending on your models as well. For us now, like we will do it in urban spaces because we have the models trained and we're sure how they are doing it. But for a new project, maybe, I don't know, maybe we will save the data first and then check.
Thanks.
Well, I've got a question. Because you've, on the graphic, there were shown 6 points or something that you're training on the detection of people that... My question is, have you tested it on other points, maybe not streets? How does your algorithm... Is your algorithm very... does it handle other scenes well, or have you tried this?
So I think now the worst scenario is like in Barcelona, possibly because of the shadows, the trees, and the people. But for instance, if we test the same algorithm in highways, like the accuracies are higher because the highways have like the same color in the ground. There are no trees above them. So I think normally, like if you start from highways and then you go to a city or something like that your algorithm is not going to perform as expected. But if you're already in a difficult situation, it's good. Also, this was trained also. Well, this was also trained with images at night at the end because we were recording 24 hours. So in this way now this algorithm is kind of robust because it has been fed with a lot of images. But this is I think that you do either all at once, but with time you start to see which type of images you have not processed or have not trained the algorithms, and so you see that it's failing there. So you can just retrain it and improve the accuracies with the different projects that you have or like different necessities.
You've mentioned you've tested it on the highways, yes? And what other places have you tried it?
Well, this one just because it's urban spaces, so to have cars, it's only our cities or highways. But for instance, if we were monitoring a room, we will use a different algorithm. Or we will apply transfer learning because in this case, you are just monitoring people in different conditions and in different spaces. So it will not perform as good here.
Thank you.
Maybe one more question there.
You mentioned, I guess, running the models on the edge. Do you have plans for I guess, deploying different models, like over-the-air updates and things like that to the cameras or things like that? Or maybe reusing the cameras for other projects in the future? Or maybe you're looking for different things?
Yeah, this depends on the project because there are some projects, like we also do this in retail, so in retail stores. And in this case, you cannot reuse the cameras because the people of the store keep the camera. But when we install the cameras in Barcelona, we can reuse them because we install them and then we take it out. Because depends on also the agreement that you have with the partner in that case.
So if you can take them out, is that how you service them and upgrade the software, or do you have like over-the-air updates?
Usually, we just enter the cameras from our space and we are able to change whatever we want.
Okay, so you do have to pull them down to change them. And okay, thank you.